Hey everyone, do you know about the star that Allah Almighty swore by in the Holy Quran? The entire surah is even named after it, Surah At-Tariq. Let's explore this mysterious and fascinating object and find out why Allah called it At-Tariq. The star At-Tariq, also known as a neutron star or pulsar, is actually very small in size, with a diameter that ranges between 12 and 20 kilometers only. But despite being tiny, its mass is incredibly huge, sometimes reaching up to twice the mass of our Sun. For those who might not know the difference between size and mass, size refers to the space an object occupies, while mass is the actual weight or amount of matter it contains. Now, if we compare the Sun and the neutron star, the Sun looks much bigger, yet the neutron star is more massive by 1.5 to 2 times. In the universe, the mass of any object, whether it's a planet or a star, determines its gravitational strength. The higher the mass, the more it bends space-time beneath it, and the stronger its gravity becomes. Because the neutron star's mass is extremely high and its size very small, it spins around itself at insane speeds, hundreds of times per second. Some neutron stars can spin up to 800 times every single second. This rapid rotation causes the star to emit powerful magnetic radiation in 2 opposite directions, upward and downward, in the form of X-rays and gamma rays. As these beams rotate with the star, they create the pulsing effect that makes the star appear as if it's blinking on and off. If those signals were converted into sound waves, they'd sound like knocking, just like someone knocking on a door. Now listen carefully.
This is the sound of the pulsar. Can you hear it? That's why Allah called it At-Tariq, the knocker. Subhanallah. Let's do a fun experiment. What if we place the Sun next to At-Tariq? You can clearly see the massive difference in size, but when we speed up time, you'll notice how At-Tariq's gravity starts pulling gas from the Sun, tearing it apart bit by bit until it completely absorbs it. Neutron stars are incredibly precise in their spin rate. Their pulses repeat at exact intervals that never change, even by a fraction of a second. They are so accurate that scientists say they're even more precise than atomic clocks, the most accurate timekeepers humans have ever made. That's why astronomers sometimes call them the beacons of space. In the future, if humans ever travel deep into space, neutron stars could act as natural GPS systems, helping travelers locate their position, speed, and even measure time accurately. But where do neutron stars come from? When a massive star reaches the end of its life, it explodes in what's called a supernova, one of the most powerful events in the universe. Depending on the star's mass before it explodes, it will end up as either a white dwarf, a neutron star, or a black hole. If the star is medium-sized, like our Sun, it will become a white dwarf after it dies, in about 5 billion years. If it's much larger, like the red supergiant Betelgeuse, it will collapse into a neutron star, just like At-Tariq. And if it's even bigger, it will turn into a black hole. Now imagine this. At-Tariq has already devoured nearly 3/4 of the Sun in our simulation. After about 50 days, the Sun completely disappears, absorbed by the neutron star. Its size grows tremendously, reaching a diameter of over 219,000 kilometers, up from just 16 kilometers, as it consumes the Sun's matter. Interestingly, back in the year 1054 AD, people around the world saw a bright new star appear in the sky that lasted for 2 whole years. In Europe's Dark Ages, many thought it was a curse or a sign of divine anger. But astronomers from China, Japan, and the Arab world recorded it carefully in their manuscripts, proving it was visible worldwide. That explosion was a supernova, and the remnant left behind is now known as the Crab Pulsar. Located about 6,500 light-years from Earth, the glowing gas around it is called the Crab Nebula. From it, 2 beams of gamma radiation shoot out, powerful enough to pierce anything in their path. That's why Allah described it as Al-Thaqib, meaning the piercing one. If we could get closer, we'd see how its enormous gravity warps the very fabric of space-time. Let's imagine landing on its surface. We'd have to stop time just to do it safely. Once there, the star spins so fast, about 30 rotations per second, that it would make us dizzy just watching it. Its diameter is about 20 kilometers, and its mass is roughly 1.5 times that of the Sun. As we move away from it, space-time begins to straighten, and the surrounding darkness returns to its natural calm. The view is breathtaking. Beams of gamma light stretching for millions of kilometers into space. And because of the star's immense gravity, time passes slower near it. So the few moments we spent there might equal years on Earth. A reminder of the